Alright, this is the Everlast PowerPro 256. It can function as a Tig Welder, a stick welder, and a plasma cutter. Right now, let's quickly go over how you set this up specifically to be a Tig Welder, wire connections and gas connections and power connections and such. And immediately, if we zoom into there, you can see right here at the right, we have the one big wire with the connector at the end. That this is supposed to be the ground connector, and you see this little slot, or not a slot, but rather a key here, and that fits into a key in this connection, or rather in this female connector, and you can't fit it in any other way. There's only one little slot in that female connector, and when you turn it to the right location, it'll fit right in, and at that point you can still put it right out, right? So what you do is, after you align the key with the slot and put it all the way in, you slide that and it can't pull out, because now the key is inside an alternative female slot, or rather groove, in the machine connector. And now that wire, that one big wire, goes down through this little loop into this ground clamp. So this ground clamp, as you can see, the wire is just one big piece of copper stranded wire, and it goes into more copper. Here's a thread, copper nut with the plated steel with the spring at here, so that there's a lot of tension applied. There's also a copper braid between the upper and lower parts of the clamp, as you can see, that braid, so that you get even better electrical conduction. And you just clamp that onto your steel table, and then the next step in electrical conduction becomes your table, and the next step after that becomes your workpiece, say your aluminum welding. So that's how the conduction goes through from the connector, through the copper, into this copper, then the steel table, then the aluminum, and bam, there's your negative or positive side, or an alternating current, your both negative and positive sides. And then the other big piece here is, for TIG welding, you have the wires that go to the gun. In this case, it's just one big wire, of course, with a control wire that's separate. Right now, let's just talk about the one big wire that goes into the TIG gun. And again, you have that same round rod with a little key at the top here, and you just fit that. After you fit that into this specific slot, you gotta rotate it, and it'll just slide right in. And then you turn that again, just like with this one, and it won't pull out. So that's how you get a nice connection on both of these. And then here is these two in the middle. Let me show you. Okay. So the silvery one here is the control connector, and there is a screw-on fastener. So you just unscrew that, and you should be able to pull it out. As you can see, there's a bunch of female pins here, but there's only actually 2 pins used. So what the button on the TIG welder does, or the TIG welding gun does, right here, this red button, is it closes the switch between both of these, which means that it turns the switch on as you press the button. So there is electrical conduction between these 2 pins when you press and hold down the button, and when you release the button, then the electrical conduction between these 2 pins is broken. So that's how the electronics inside this TIG welder / other function machine knows when you press the button or not, by just knowing when electric current can pass through these 2 pins or not. And again, this has a little female slot, and there is a male dimple here, so that you can only arrange it in the one orientation. And all you have to do is you have to find that orientation by rotating the male pin, and then when you've got it, it just slides right in. Then you screw that fastener right in there to make sure it doesn't come out, and that works out pretty well. Then there is also the gas, and this is for your shielding gas. Shielding gas to protect your weld from the air, which contains oxygen. Oxygen in contact with air, oxygen in contact with your welding material, in contact with the metal, at high temperatures makes it very easy for oxide formation. The metal reacts with the oxygen to form metal oxides, and those weaken your weld as well as preventing you from continuing welding, because oxides have a large melting point, especially with aluminum. So how you fit this on is, it's the quick connect, and how the quick connect works is there is a little spring mechanism that pulls back on a bunch of ball bearings inside, and as you press this, the ball bearings will retract, and then you can fit this with its groove right in there. And then when you unspring this backwards like that, so first you spring it forwards, retracting the ball bearings, and when you let it go, then the spring is going to expand again. The ball bearings are going to fit right in this groove here. I'll show you what I mean. Aha, you hear that click? That's when the spring has retracted because the groove was in the right location. Now the ball bearings in the groove are preventing the male quick connect from going out. So that's it for the front side. You see the two big wires. So one is for becoming the ground clamp into the material being the conductor, and then the other one is for going all the way through the copper wire, one big copper wire into this tungsten electrode, which then becomes, of course, your negative or positive or both in the case of alternating current. And yeah, what happened now is you just have current that goes from here to there and here to there, and that's the front side explanation. While shielding gas, of course, constantly pours out of this cup. And you control how you weld with the button, and that's it for the front side. Now, how does the machine get its power, and how does the machine get its gas? That's the thing. We know that there's just a switch here, there's a current flowing from this to this, and there's gas flowing from here into this gun. There's as you can see, there's the hose, and then there's the heavy wire. So this heavy wire is for the electric current, this hose is for the gas, and then when the gas goes in here, through here, and shoots out of that cup, and it just shields it up. Yes, okay, I don't want to spend too much time with this. Alright, so this is the back of the Everlast machine, and as you can see immediately, there's this big thing, and with two ports, one inlet, one outlet, and this is actually just the water vapor filter for the plasma cutter, and you don't need to worry about that for TIG welding. And then here are two alternative connections for putting in your alternating current at 220 volts, right here, or down here. And in this case, we're actually using the lower input, and it'll be coming out from here into here. So it's 3 wires, and there's an extension cord right here, as you can see, like that and like that, and you just put that in there, then the extension cord goes into here, and your mount stationary female socket connector as usual. Okay, so that's it for the power of the TIG welder, and now let's cover the gas. So the gas, as you can see, there is a brass barb that connects to this silicone tube, and this tube is held onto the brass barb with a hose clamp connector, and that's just, you need that clamp, otherwise you'll have leaks of your shielding gas, and yeah, leaks in general, not good. And the tube, if you trace it along, you'll see that it goes into this regulator. So this is the gas regulator for the flow rate to be adjusted. So in this case, this particular argon regulator, we have turn it clockwise to shut off the flow or lower it, and then turn counterclockwise to open up the flow. And there is a little ball bearing inside there, and depending on the flow, you see an increase in that ball bearing. Yes, and then there is the pressure gauge that tells you what the pressure of the tank is. And whenever you want to use the welder, you just turn this on. You see that pressure gauge indicating the pressure of the tank, and then if you turn this on, it won't have any flow because it's a good airtight seal here, it's a good airtight seal at the back of the machine here, and the switch of the TIG gun is not turned on, hence there will be no flow, zero flow. But if I do press the trigger while this machine's on, it will flow. Other than that, just make sure you have that. There's another barb here. It's not brass this time, it's stainless steel. You still want that hose connector. And alright, so for the purpose of explanation, I've taken off this regulator, and let's just examine the connection part in more detail to the canister of gas. You see there is this round port with a little porous copper inside here, or copper or bronze, or maybe brass, and then this little nut piece, or not a nut piece, or bolt piece here. So how it works is, as you turn this bolt, this hollow bolt, I guess that's a good word, you'll get a compression at the round piece, and that'll form an airtight seal on the canister. Now let's examine the inside of the canister to make sure exactly we know what the interface, how it works. As you can see, there's no like rubber inside there, it's just metal, and in this case probably brass or bronze, probably brass, and of course you see those female threads all around, such that when you put in that bolt from the regulator, the rounded part, as we saw before, this round part is just going to fit inside that, and then you're going to press up against it so hard that you get a good seal. Okay, so let's go over the installation of the regulator onto the canister. When you get this canister, you're going to get it coming with this cap on the top, and that's to protect this top from breaking should this canister fall over and hit something. And if it hits something, all that gas is going to come out through probably a leak that happens somewhere during a leak that happens through a crack after it breaks, and that is very, very bad, especially if you're dealing with, say, compressed oxygen, because that's very flammable. So yes, you're gonna have this cap that's gonna be threaded on, and after you get this canister and you firmly mount this canister so that it's not gonna fall over with any easy budging, then you can remove the cap here, and then before installation you want to release some high pressure gas to remove the contaminants like dirt from the female port of the canister. Install the regulator, then you can turn on the machine by switching on the circuit breaker. Optionally connect the machine to earth with copper wire to copper or stainless steel rod buried over 2 meters in the ground. Let's cover the TIG gun and its assembly. So it'll come with the frame up to here and there, and the switch will be there. This part down here will come probably too. And let's see this TIG gun and take it apart, then put it back together. As you can see, the tungsten's sticking out only a few millimeters, or 1/8 of an inch. You don't want that to be sticking out too much, otherwise you won't get good shielding on your weld. First thing to see is, ooh, what's this big thing back here? Why does it have to be so long? The reason is the tungsten rod that you use is pretty long, as you can see. So you want some kind of hollow back there. There's a big hollow down there, so that you can just fit this cap over it and make a nice seal there. And in fact, this also has another function. As you tighten down this end cap at the back, you also are tightening down the collet, and I'll tell you what I mean by that very soon, right here. Aha! So as you can see, there is the tungsten rod. In this case, I'm using 3 32nd inch 2% lanthanated tungsten, and we have that as our lanthanated tungsten rod, and I'll set that aside. And then we have this, which is the collet. So the collet is essentially a little tube of metal that has a slit, usually triangular, 1, 2, and 3, in a triangular fashion, as you can see. If you see from the front, maybe that's a bit too small. So I hope that makes it clear. So those 3 slits allow this collet to compress onto this tungsten rod if it goes into another narrow slit, and I'll tell you what I mean, and I'll show you what I mean by that very soon. So how you attach the rod onto this collet is you just take the rod, the back of it, and then you just make it go through this collet right here, and it'll go through at the other end, and your working end of the tungsten is here, and your collet's curved section should be also pointing in the same direction as the working end, and I'll explain why very soon. How it works is you have the end cap that goes back here, goes over this extra tungsten that we have, and then presses on this larger groove, and as this end cap screws in, it produces a force in that direction, and then the collet is actually sitting inside very much something like that, like my fingers are doing, and as it presses on, the collet tightens up against my finger-like frame, and then hence tightening onto the rod. And I'll show you an example of that right now. So let's put the tungsten with the collet with the end cap here, and let's not tighten it very much at all, as you can see. And now in this case I can willy-nilly move the tungsten piece, right? So that's not good, it's a willy-nilly piece. And then when you tighten this, what's happening? The collet is getting compressed, the front of the collet with the slits is getting compressed, and the tungsten is hence also getting compressed, and then I can't willy-nilly move it anymore. How does this happen? Let's see it in more detail by also examining the front assembly. So let's remove the end cap, the tungsten rod, and the collet, and now take off this ceramic cup. The ceramic cup, the reason the ceramic is because it has extremely high resistance to high temperature. It doesn't melt very easily. And when we take it off by unscrewing it, we see, okay, this is not ceramic. This plastic white piece should be able to come off. There we go. So this piece just fits in the back of the ceramic piece, just as like a little seal to be placed right here at the front of the gun, as you can see. And yeah, let's leave the plastic seal and the ceramic down there too. So, wow, what is this? So this is another little, I guess you could call it an electrode holder, and you can unscrew that from the gun. So this gun, what you start off with is this entire assembly here with the female thread at the front and the female thread at the back. And then first off, you probably want to attach this piece. You'll see like a little dome-shaped groove in the dome shape at the front, and little good thread at the back, and you just screw it on like that. And here is where the explanation of the collet. As you saw, there's the round part of the collet with those slits, and inside there, if you can see very, very closely, there's yes, that would be a good way to do it, a narrowing of the tunnel, so that the more you fit this collet into this tungsten holder, collet compresses onto the tungsten. I hope this is a clear enough explanation of how the collet functions. Okay, so yes, let's reassemble this. So first, the tungsten holder, making sure that the dome is at the front, and then in fact you can't even assemble it like this, so you don't have to worry about it so much. Just the right thread at the back. Okay. Good. Just turn it like that. Maybe you want to give it a bit of a tightening with the pliers, but right now it's okay to just do it with your hands. And then you attach that plastic piece. It'll fit one way. It can't fit the other way very well. So it'll be good. Now let's fit on the ceramic cup. And again, this won't be able to fit on very nicely like this, so you'll only be able to do it one way. And you'll, of course, if you just for the sake of doing it right the first time, you'll see that it's a dome-like shape where you're supposed to mount it into, and it's a relatively straight piece where you're supposed to have the front of the welding gun. And you can just screw that on to you can actually, how you screw this on is also important. There is a female thread inside this ceramic cup, and there, as you can see, there is this rough, coarse thread on this tungsten holder, and that's how the interface works out. Alright, so now we've got the tungsten holder and the plastic seal and the ceramic cup in place. Now we can work with the back. Again, you want to insert the tungsten with the working end in the same direction as the collet to dome end, and then you can just place it right in here. You'll see the tungsten at the front side there, and that's good because you'll be able to adjust to how much tungsten goes in later. Now we take the end cap and just kind of fit it in, and yeah, you don't tighten it too much. You adjust the amount the tungsten is there by, and then bam, you tighten it up. Collet gets compressed into the tungsten holder, and it's not willy-nilly moving anymore. Probably want to put that down a bit. Maybe sticking out too much, probably. Yeah, that's it for the TIG welding gun assembly. Now here's something very, very important that you got to do if you want to TIG weld, especially aluminum. When you get your tungsten and you install this entire gun, you got all your ports for your TIG welder all nicely hooked up, and you're ready to start it up and start welding. And then you're not going to get a weld. In fact, you're not going to get a puddle at all unless you prepare the tungsten tip properly. And the way to do that is one part of it is to bench grind. So you take a grinder, benchtop grinder, or even a grinder, but probably want to do a benchtop grinder for making the whole process easier. You apply a large current, say 170. In fact, I'll show you. So not that high, maybe 177 or so. So in that range, about 150 to 200 amps. Of course, it depends on how large diameter your tungsten is too. But right now, for our 3/32 3/32" diameter 2% lanthanide tungsten electrode, the about 170, 180 is alright. What you want to do is take a piece of copper plate, or in fact any object of copper. Make sure that it's got its conduction to the. You apply DC, and using the 170 volt. Okay, so maybe go further on the steps. So pulse off DC. 2-touch for ease of operation. TIG, forget about AC frequency, we're not using that. Current set 170 to 180. Free flow at 3, post flow at 3 or so. Upslope 0, downslope 0. Start amps and end amps 5. Start and end amps is not so important when you have extremely low up and down slope. So yeah, okay. So then, essentially what you're doing is you want to apply a high current from the electrode to the copper, and copper is used because it's a good conductor, just good conductor. And what will happen is you'll get a nice ball at the end of this tungsten, and that ball, that clean ball, will allow you to weld much better than you would without this process. So this is very, very important. You try welding without this process, it will not puddle. You'll get all sorts of nice black and white and blue oxides, and it's not gonna happen. I've tried it, trust me. So to reiterate, the process is you take a piece of copper plate, you make sure that it's on the table, on the steel table or other table that's conductive, connect it to the clamp, and then you put the proper settings, as I said, or depending on your application, depending on actually not your application. Sorry, depending on your tungsten composition and diameter, and then you get very close to the copper, you press it, and it goes like, and then you release it, and then as it cools down, you'll see a little ball forming. If it's not big enough of a ball, then you want to do it again. If it's too big of a ball, maybe you want to cut off the front piece of the tungsten, release the collet pressure, move it back forward. And then try it again with another section of the tungsten. That's why the tungsten is so long. Leaves you room to cut off the front ends if you make an error or something, contaminate the tungsten, and then try again. Yeah, so make sure to do this. And that's it actually. So we've covered how to install the connectors to the right ports at the front and at the back, how to turn the machine on, how basic guide to how to configure the settings here for TIG welding, and of course the very necessary balling up of the end and grinding up the top too. That helps too. Grinding the tip, and yeah, those are the three things: ports, settings, tip. That's all you need to know. And then there's the welding.